Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
Okay, I'm going to be honest. Obviously, I really get excited about weather, but I do need to give a little preface right here. All right, before we talk about our most destructive clouds that we have here in the mid-latitudes, let's make it clear that I live in California. I have super mild climate for most anywhere else in the world. Right? Especially for my poor friends that live on the eastern side of the Rockies. They get really crazy weather. California, because we have that cool water off of our coast, pretty mild most of the time. Okay? So I get very excited about the weather. I enjoy talking about the weather. I enjoy talking about the clouds. Do I need to worry that there's going to be a tornado tearing my house apart? No, because of where I live, I'm in a safety zone. So for those of you that have lived or do live outside of the area and are dealing with these crazy weather conditions, my heart goes out to you. And I don't mean to make light of what you're facing. I make a big deal and I get excited about these things because the process that goes into them is very exciting. The destruction, very scary. So, that being said, let's talk about cumulonimbus clouds. Now, we've looked at our cloud identification before. Cumulo means vertical development. Okay, vertical versus horizontal. I always remember the horizon is horizontal. So we know that these guys are going up, right? These are going to be vertical development. And we've got that suffix nimbus, like the Nimbus 2000. I don't know why you'd call it nimbus, because nimbus just means that it's going to be rain. Or not really rain. Let's preface this by saying precipitation. So it's the precipitation 2000 that he gets so excited about. I don't know why. Okay, so it's the Nimbus 2000. No, it's the Cumulonimbus 2000 cloud. Okay, there's no 2000, right? So how do these guys develop? Well, we talked a little bit about cloud development in other videos, but what we have is we're going to have humidity and condensation nuclei, and we make that rise. The best place to get the most impressive cumulonimbus clouds in all of North America is going to be on the eastern side of the Rocky Mountains. Why over there? Okay, well, those Rocky Mountains are going to be going up, and what those Rocky Mountains really are doing is they're isolating CA and NV and AZ and let's see, Washington and Oregon, all of these other states that are over here on the other side. Okay, we have the Pacific. And that's nice and cool water. But over there on the eastern side, we got the little Appalachians going on right through there. On the other side of the Rockies, that's where the crazy things are happening. Okay, what does this look like again? Well, in other videos, we've talked a little bit about this process. Let's just put a big N right here, and we'll put a south right here. This is going to be up in Canada. This is going to be in the Gulf of Mexico. We're going to have very warm and humid air, and the abbreviation that we use for that is going to be maritime tropic, little m, big T, right? And then we're going to have, oh my, up here in Canada, it gets very cold, and cold air does not like to hold very much water vapor, so dry, and we're going to call this continental polar air. Right. Now, what we want is we want that advection, we want our continental polar air to start to get a little pushy. Okay. As it does that, remember that this is going to be more dense as well. And so, boom, we get this very, very cold front. Okay. With that cold front, what does the maritime tropic air have to do but to get up and out of the way? And so, whoosh, whoosh, and whoosh. This is going to be very Okay, another reason, right? Let's think about Alaska. Let's think about Washington or British Columbia and the weather there, the temperature and the humidity there versus San Diego. Okay, over on our side, sure, yeah, we're going to get cold air coming down. We're going to get warm air coming up, but nothing like over there on the other side of the Rockies, where we're going to have the air from the middle of North America, the tundra, if you will, of Canada coming down. Very, very cold. Hey, San Diego, it sure gets a little humid sometimes, but the Gulf of Mexico, it's hot and humid all of the time. Okay, maybe not all the time, but most of the time it's hot and humid, okay, all along the eastern seaboard because of the water being very warm. Okay, so that difference between these two, significant. Okay, when we do this, this is going to be lift. Okay, it's going to be very rapid. It's going to be a vertical. Okay, and what does that bring to us? Well, it happens to bring us vertical development. Okay, so that's going to be a cumulus cloud over there as well because of the differences between these two. It is a huge impact. Okay, a lot more humidity as well. And that humidity, remember, as that humidity rises, the air gets colder. As it gets colder, we get condensation. And boom, that condensation is going to be our cumulonimbus cloud. Okay, in the next few videos, we're going to be talking about some of the fun and adventures. No, if you live there, then they're terrible and devastating. That's what I started the video with. Okay, some of the things that happen out of these cumulonimbus clouds. Okay, it's really pretty crazy. Yes, here in California, we see it a little bit. But over on the other side of the Rockies, Tornado Alley, boom. Tornadoes, one of the features. Lightning and thunderstorms, boom. Hail the size of softballs, boom, all over there. Okay, so we're going to see a little bit of these guys over here, much more significant there, and in other parts of the world.